Hello, let's start with the circular motion lab. As with any lab, I strongly suggest to play with the apparatus to see how radius indicator works, how speed regulator works, and what is the maximum speed that you can reach. Try to push on and off. Try to measure masses of the individual objects. Make sure that the regular discs, small cylinders, have the same mass as their twins with a hook. We will be using for our two parts of the lab masses with the hooks. We will explore centripetal force, and for measuring the force we will use force sensor. We could use any mass of our choice. My suggestion is to select a couple of masses. It's up to you which mass you select. In this example, I selected one mass equal to mass of object A, and then I tried to explore what will happen if I will double the mass. And then you will place your you will select your speed to a certain quantity. I've selected for example 15 RPM. That will be your target speed. And then you place your object in 4 different positions between the center of the rotation to the edge of the disc subsequently. And once you place your object, you adjust your radius indicator so your center of the object will be exactly coming through the center of your cylinder. And that is how you will measure the center of radius of rotation. So when your center of the object is lying on the green line, that's your radius. You will record your radius in the first column of your Excel file. When you start rotation, you will see that force sensor will start showing increasing numbers, and this increase will correspond to increase of angular speed. Once your angular speed reach target speed, which is 15 RPMs or 1.57 radians per second, your force sensor will settle for a number, and that's the number that you will record in column 2. Then I selected double mass just to see how force is affected, and recorded it in the third column. But you may select different masses and just see how mass affects the force. So instead of using double mass, you can replace your object A with the object C. Just make sure that whenever you replace them, the radius stays the same. I need you to explore two masses, mass 1 and mass 2, at least 5 different radii. So you will place your object in 5 different positions, bringing it and measuring the radius using radius indicator. The more positions, the more different radii you have, the better is quality of your job. Once you have 5 to 10 different radii and measurements for your force, I want you to plot the graph. I will explain how to plot the graph in our second part of experiment, when we will settle the radius. We will keep the radius the same, but we will change our target speed. Let's select our radius of rotation to be somewhere in the middle, right? Let's measure what is our radius of rotation. Here we go. Radius of rotation equals 11.87 centimeters. And now I will vary my angular speed in radians per second, and see how my force on the force sensor will adjust. And again, I will select two different masses. Let's select right now MC and triple MC. I know that my mass of the object C, let's put it on the scale, single mass is 85.60 grams, and if I triple it, triple mass will be 256.80 grams. Okay, and now I'm ready to change my angular speed and see how force will be affected. My initial angular speed will be 0. Wouldn't be nice to start? When my angular speed is 0, no matter what mass I use, the force sensor shows 0, and that should be recorded as 1 point. Now, I will place my object at my fixed point. The radius will be always the same. I place it there. And now I will start increasing the speed. So my first angular speed will be 1.13, and force for single mass 0.0132 newtons. And if I double the mass, I will have double the force. Is it a coincidence, or is it something to expect? Let's change to different speed, recorded. For example, if my angular speed now is 212, my force with single speed will be 0.0461, and I forgot that I needed triple mass, right? Not double mass. So this one was incorrect point. 18 newtons. I can try and return with triple mass to my initial angular speed and see if I can reach this point. Since my speed is constantly adjusting, it could be very difficult to reach the same point, especially on my computer. So I will just skip this point and I will go further. I will have plenty of opportunities to run my 5 to 10 points for the graph. So single mass shows 0.0845, triple mass shows triple force. So it looks like it is not accident, but we could check if that is something of deeper nature, and change another speed, select another speed and add more points. That's my triple force with triple mass, and that's my single mass and single force. Again, I need 5 to 10 points to really make sense of my lab. So I'm recording another speed and 2 more forces in the table. Once my forces are all recorded, and again, you're more than welcome to do more points. That will be big fun for us. You see that apparatus is stopping and my force was decreasing as my angular velocity decreased. Now, I will show you how to plot the graphs. You select all your numbers, your cells, select one cell, and then you select one and drag through the whole area. Then you click on Insert, Charts, Scatter Plot, select Scatter Plot, and now you see this is not like straight line. It is kind of curved line. So when I select my trend line, let me try different options here. Straight line is not working. Logarithmic? No, it's not working. What do you think? What it looks like? Try different. Polynomial of order of 2 looks good to me. Let's try of order of 2, and let's display our equation. Now, what I forgot to adjust is our overall requirements for the graph. So my bottom line will show angular speed in radians per second. My vertical axis is still showing force in newtons. So when I find my trend line, polynomial of order 2, I will have my equation written there. Once you plot both equations, I want to see how your parameters change. How they correlate with each other. No, you don't need linear. You need polynomial. You see we had triple the mass. Look at main factor.